Thanks for having me. My name is Max. I work for SAP, and I have the honor to introduce you the project Confidence, which is a framework for delivering microservice-based SaaS applications. Before we come to that, a disclaimer, Christian already mentioned it. This is the current landscape of the NeoNephos Foundation, and we see a lot of good projects there, but Confidence is not yet there, so it's missing because we are not open source yet. This is only planned for the second half this year. So just as a disclaimer, don't be surprised if you do your research on the internet, if you look around for confidence-related documentation, there will not be anything besides a small announcement page. And since we already at the beginning, since we are in an early stage and only at the beginning of our open source journey, some things in my presentation, like names, architecture details, and stuff like that, are not yet final. So if I come again in half a year, some things might have changed. That being said, where do we fit in here on this slide? Confidence is basically a sophisticated deployment operator. So we run on Kubernetes, so for example on Gardener, and we have a couple of touch points with other projects on that slide, for example, with the open component model. But we come to that later in the course of the presentation. I wanted to start with an open question. What is an application? Because when trying to understand what problem Confidence wants to solve and what our main use case is, it basically turtles down to this simple question. Actually, it's not a simple question or not straightforward to answer. When I ask my developer colleagues this question, I usually get an answer which goes into this direction. So an application is a microservice, a Helm chart, Docker image. And while this is not wrong, it obviously depends on the context you're in. We tend to see things from a technical point of view. So I wanted to ask a business guy the very same question, but because I did not have a business guy at hand, I opened my AI chatbot and prompted something like, you are a business expert, please answer me this question. And the result was this statement. So an application is a deliverable unit of business value, and it has a continuous life cycle. And to be honest, I was not disappointed by this statement because it emphasizes two things. It brings up the question, how can we efficiently deliver business value to our customers? And how can we do that in a continuous way? And why do I like this answer so much is because that's exactly where Confidence originates from. I work for SAP, as I said, and we as SAP, we are selling business apps. And we have an internal predecessor for Confidence, which we built together with large-scale business applications. And we built this together with this application based on their needs for continuously delivering business value. And this is where the ideas and the core concept of Confidence are coming from. So we are implementing Confidence from scratch, but the ideas behind it and the concepts behind it, they are battle-proofed. So we are doing this since a couple of years. And to more clearly set the context, we are talking about business applications with tens to hundreds of microservices. So our target group are really big microservice applications with a continuous delivery flow. And if you have ever developed such an application, you are for sure familiar with the pain point of delivering such applications. It's the operational overhead. So bringing things to production when lots of developers and teams are involved is a very complex thing. Without breaking API contracts, so that every piece of the software fits together. And this pain, you can measure it. That's exactly what the DORA metrics are about. Basically, the DORA metrics report says that your organization will be successful if you are successful in the DORA metrics. And that's our vision. So we want you to be to master the DORA metrics, and we want you to ship your code in small increments daily, or even better, on demand. But when we look in detail on the DORA metrics, there is always this tension between the throughput KPI, so delivery frequency and mean time to change, and the stability KPIs like change failure rate and stuff like that. And this tension is exactly where Konfidence steps in and can help you. So I took this quote from one of our marketing documentation pages, which is not official yet, but only internal available. And it says, Konfidence is a delivery framework for microservice-based SaaS application and has the following key characteristic. It uses immutable versioned application versions called what we call a vector. It enables automated low-risk zero downtime releases, and we help you to improve the DORA performance and reduce your total cost of ownership. To be honest, I like more the tangible description that Konfidence is basically a Kubernetes operator for application lifecycle management. And we start by describing the application, or defining the application in YAML with a Kubernetes custom resource, and we end with running pods. But before we go into the deep dive how we achieve these improvements in DORA and TCO and so on, let's talk about some core concepts. And the first three things I wanted to discuss are not really Konfidence specific. These terms are pretty much well known. I just wanted to mention them so that we are all on the same page. So when we talk about software artifacts and their configuration, we usually refer to the result of the developer's work. So of the result of a build pipeline, for example, a Docker image or a Helm chart or stuff like that. But also product-specific configuration like feature toggles and translation files and so on. When we talk about landscape, or landscape is typically a Kubernetes namespace. Sometimes we also call an entire Kubernetes cluster a landscape. And a landscape has one or more stages assigned. And the important thing about landscapes is that it's something physical, something where we can physically deploy to. Whereas opposed to this, a stage is a virtual thing in Konfidence. A stage has a vector assigned, but it is only a virtual thing which we use for grouping things. Now let's come to a couple of Konfidence specific terms. So I already mentioned the vector, and that's the core entity or the core concept in Konfidence. A vector is basically a mutable set of versionized software artifacts, including their configuration. And it basically describes the entire desired state of an application at a point of time. And one important property of a vector is that it can be qualified. What that means, I will explain it in a minute. And then we have a vector deployment. A vector deployment is the instantiation of a vector in a specific landscape. So the deployment of the artifacts in that vector in a Kubernetes namespace, for example. And we have the term promotion, which describes the action of moving a vector from one stage to another. And on the right, we can see a small diagram. So there is a landscape which consists of two stages. And the development stage has a vector, a slightly newer vector assigned as the production stage. I have to move that window here. Sorry. And as said, the production stage has a vector which is slightly older because there is this full service in the development landscape, which has a new version. So we talked about what properties a vector has, but what is actually a vector? It's no magic. It's basically a an OCM component, so an open component model descriptor, which is written in YAML. And a vector consists of references to other OCM components. For in this example, we have two references, and this first reference of the foo service reference to another OCM descriptor, which describes the foo service in more detail, and it has an actual resource property here where you can specify, or where you specify that it's a Helm chart, and it's where you can find it. It's an OCI artifact, and there is a reference to the OCI repository where we could download it. Mhm. So now let's take these terms and apply them to the following example, which shows a typical, what we call stage-based delivery flow, in this case, across three landscapes. So we have these three Kubernetes clusters or namespaces, and we have these four stages. And the initial situation is like this, that all of the stages have the same vector deployed. So they point all to this vector. So when we create a new service, a new vector, which usually happens in your development stages, basically every change to an artifact inside of a vector will trigger the creation of a new vector. And usually that happens in your dev spaces. And at some point, you take the decision that your development is finished and now you want to bring this to production. That's the point where the promotion flow starts. And the first promotion is from your development stage to your test stage. So your test stage now points to the new vector. And now you can run all kind of qualifications on that vector in your test stage. So for example, functional end-to-end tests or security validations and so on. And when all of these qualifications, when the result is good, then you can call your vector qualified. And then usually you trigger the last or the next promotion, which is then the promotion to your production landscape. But before this new vector reaches your actual customers, it's only deployed to this pre-production stage, where only you have access to, or a small user group has access to, and you can then log into your application. So it's actually deployed in production. You can log in there, you can click around, see that everything is working. You can also run automated tests on it if you want to. So basically you have two versions of your application deployed at the same time in your production landscapes. And when you are fine with what you see on your pre-prod stage, then you can trigger the last promotion, which is then basically just a switch in traffic routing of your actual production states where your customers are to the new vector. So there is no new deployment involved in this last promotion, and it's just a reconfiguration of the traffic management in your cluster. As I said at the beginning, we have a predecessor, an internal predecessor here at SAP, and this stage-based delivery flow is basically what happens for our internal stakeholders on their daily basis. So they do this promotion flow from development to production. Most of them do this fully automated every day, and that's our goal. So at the end, we want that you gain so much confidence into this process, into this release or delivery flow process, that you that it's nothing special anymore. It's like brushing your teeth. It's like everyday task you have to do, and you do not have fear that something will break or something like that. Let's look at another example, which depicts the routing and the artifact reuse features of Konfidence. So the initial situation is like that. In this case, that we have production stage, which points to a vector. And we see here on the bottom, the customers are routed to this vector deployment. Remember, a vector deployment is the instantiation of a vector in a certain landscape. So in this example, it's the deployment of this foo service and this bar service, and we configured the routing resources, in this case, the Kubernetes Gateway API, so that your customer is routed to the correct vector deployment or to the correct backend services. So what happens now if your developer pushes new code changes? A new vector is created, and at some point it will be promoted to the production landscape. And what happens then is that Konfidence calculates the difference between the two vectors. And in this case, it's really simple. The difference between the two vectors is the foo service, because this has an updated version, but both vectors share the same version of the bar service. And what is then deployed, so the new vector deployment for the second vector, it shares the artifact for the bar service, because this is the one which did not change from when comparing the two vectors. And the final promotion is then, or the switch in the promotion is then that you just reroute the traffic. We reconfigure the gateway API resources in a way that now the traffic from your customers is routed to the new vector deployment. And eventually, if no one uses anymore the old vector deployment, it will get undeployed. So takeaways. I would really be happy if you take these couple of things with you after this presentation. So in a nutshell, Konfidence is a continuous delivery platform with some service mesh-like features, because we control the traffic in your cluster. It's built on Kubernetes. It is extendable, and it's run by design. I will elaborate on this in the following slide, because I have the time to do this today. And we target enterprise scale business application, which are offered as software as a service. And our goal is that these applications improve their DORA metrics so that they can at best deliver daily. And the key selling points are the following. So we improve in DORA metrics through the automation of delivery. And we want you to gain confidence in the release process through the vector qualification. And by the way, this is where the name comes from. So Konfidence with a K for Kubernetes, but confidence stands for that you are gaining really trust into this release process. And both of these things are the CD continuous delivery platform features I mentioned. So we offer tooling for everything around vector assembly, qualification, delivery, deployment, and so on. And the features which come from this built-in traffic control, so the traffic management with the gateway API, is that we can assure true zero downtime through this atomic switch when the entire application is ready, not a single Docker image or whatever is ready, but when the entire application is ready. And we can reduce the total cost of ownership through the artifact reuse I just showed you. Okay, since I do have a little bit more time, we can postpone this slide and talk a little bit about the architecture of Konfidence, which is basically split into two control planes. So on the left side, we have the global control plane, which is responsible for the vector creation, so vector assembly and vector promotion, which means that here we define the application. We build the vector OCM and push it to the OCI registry, and then we assign a vector to a stage. This stage is synced to the local control plane, which is on the right side of the slide. And there, the synced stage resource is picked up by the vector lifecycle. So then there we download it from the OCI registry, and then the vector lifecycle begins. So we deploy it. So we deploy the artifacts to the target landscape. We execute migrations, for example, database migration or cache warm-ups or stuff like that. And the final thing is the vector activation. This is the atomic switch I talked before. Now let's look at the architecture drivers. So the first one is, obviously, we want it to be Kubernetes native. If we have a closer look at the control planes, we see that all Confidence concepts and entities are modeled as Kubernetes CRDs. And they are reconciled by regular Kubernetes controllers, which we built with the kubebuilder framework. The second thing is, I already mentioned it, is that Confidence is sovereign by design. If we cut the connection between the global control plane and the local control plane, the local control plane stays fully functional, and it does work autonomously, so to say. And you can even deploy new things there if you manually transfer or manually push your vectors to the OCI registry. So, for example, if you have an air-gapped data center, you can bring your vectors there with a USB stick or stuff like that. And the last thing, the last architecture driver I want to mention is that we wanted to integrate third-party tooling wherever it is possible. And I depicted here a couple of examples. So I already mentioned that we run on Gardener, and we are using OpenMCP for the general setup of our Kubernetes cluster. We are using KCP, which is a CNCF project, to manage control planes. So we have this one-to-many relationship between the global control plane and the local control plane. And for managing this relationship, we use KCP. I already mentioned OCM. We describe the vectors and the software artifacts as OCM components and pushing and pulling them from the OCI registry. And in the local control plane, we are using Flux, or we instrument Flux for the actual deployment of Helm charts and so on. So we are not doing this by ourselves. We are creating Flux custom resources, and then Flux will deploy it for us. And I also mentioned already the gateway API. So we create HTTP routes and gateway resources, which then will be picked up by any implementation of the gateway API. So, for example, by Istio. And if I still have time, I can do a short live demo. I think that's okay, or?
Yeah, sure.
Okay, but before I come to that slide, I have to go back to the architecture, because I said it, we are at an early stage of the development, and what we have built so far is the first functional version of the local control plane. So of this vector lifecycle, deployment, migration, and activation. And I cannot show you the functionality of the global control plane, but for the sake of the demo, that's enough. So what I will do, or what I have done before, is that I wrote YAML, a vector in YAML, and pushed it to the OCI registry, and I will assign that to a stage. But first, let me introduce the demo application. Basically we were lazy and did not implement a demo application by ourselves, because we found that Istio has this book info application. Not sure, or it might be the case that you have heard about it. It's basically a small showcase demonstration application which they use to showcase their features, and it also fits very well for our use case. And for the sake of this demo, I have created 3 vectors. So the first one consists of the product page, detail page, and the review. Product page, detail service, and the review service. And the second version has these updated versions of the review service, and it adds the rating service, and the last vector in green here updates both of these services again. So I think I have to stop the share and share my entire screen. Okay, you can see my browser now.
Yeah.
Okay, So basically, that's the OCM component, the OCM descriptor of the first vector, what I just showed on the slide. We have this product page service and detail and review service, and this is the vector OCM, so it just has references to other OCM components. I can also show you that. It's, for example, this one, and we can see here that the actual resource of this artifact is it's an OCI artifact, and it can be downloaded from this URL. In this case, it's not a Helm chart. It's basically plain Kubernetes files, which we will deploy with Customize. Since I mentioned it, we're using Flux for the deployment. We support both, so we support Customize files and Helm charts. And if we look at the clusters, so there is this is the stage, or this shows which stages are currently deployed in cluster. There is only one stage at the moment, which has this name prod. And I can show you this in my GitHub repository. A stage CRD is simple as that. It just has a name and it references a vector. In this case, we reference the vector I just showed you in GitHub. So it references obviously the uploaded resource in the OCI registry. And if I now, before we deploy the second stage, we can access that page here, and you see that's a simple book info application. It has some book info details, book details, which are coming from the detailed service, and it has this review section, and you can even see here which pod serves the response. And if I now apply the second stage with the second vector, I will create another stage for that so that both vectors will stay deployed. Oh, sorry, wrong directories. Yeah. So there is this Zoom thing here, which it does not let me see my entire screen. Oh, no, it's gone. In the wrong there. Now we are in the correct directory, and I can now apply the changed file. And if I go back to the stage overview, we see that this second stage was created. It references the second vector, it already got deployed. So we see previously there was only the detail service, the product page service, and the rating service deployed. Now we have we have this review service in another version because that was added in the second vector, and we have the rating service, which was also added in this service and this vector. But we reuse the same version of the product page service and the same version of the details service. So can you look at the slide again? Vector 1 and Vector 2, they share those both services, and Vector 2 adds these new ones here. And if I now go back to my browser, I have a plugin here where I can set a header which basically steers which version I wanted to serve. And if I now want now send a request to the second stage with the second vector, then your attention should go to this section here on the review page, because there we will have now a star rating appear. So this was added with the new vector. So basically a small new feature. If we want to see the previous version, we can just change the vector header back, and now it's gone. And we can also add the third vector. So the third vector also does the database migration, which I will not show in detail now. But basically, we will again share a couple of the already deployed services, but we will also deploy new ones. So in this example, this version 3 of the review service. And if this is then ready, I can go back to my browser and set the vector here to vector 3. And then I'll reload it. So the new feature here is that this star rating is now, it comes with a color. So it's just to showcase that there are different application versions in the background. Okay, so then, yeah, thanks for your time. Thanks for the attention. If you have questions or feedback, you can reach me via this email address or on GitHub. This is my GitHub name. I will also be at the KubeCon in March, so I'm happy to meet there. We do not have, I mentioned it in the beginning, we do not have any material online, so except for this small announcement page and a small section in the Apero documentation, which is marketing documentation and explains a couple of the core concepts and the goals and so on of Konfidence. But that's it for now. I guess in a year, we will have more, and then maybe I will come back at that time. Thanks.
Yeah, thank you very much for your presentation. And I mean, yeah, as we already said, it's a prospect project, so it's not officially being submitted to the TAC yet, but it's planned that we release that during our IPSIDE development. I think it's really good software how to do this, and yeah, looking forward in the next 6 months. With that, can you unshare? Yeah, I mean, I don't really have that much to share, but the Q&A page. So basically, I would like to open up now for for your questions, for your thoughts, for your ideas, feedback to the presentation, to the foundation itself. Yeah.
I really like the first link to the kids swimwear. I have to share that
Max
with the
Christian
team.
here.
Yeah.
So I could not see anything because I'm traveling, but I listened, and you were in the beginning talking about delivering various OCM packages, yeah. And what I had in my mind is, let's say you have config maps with a staging process, and in these config maps, you somehow, let's say, describe how you reassemble the different OCM packages together to, let's say, the bigger application, if you talk about the microservices. Is this a correct understanding, or is it a bit different?
I guess that's not what we are doing in Konfidence. We are really using or leveraging OCM as I showed it. So you weren't able to see it, but we are only using these component references, and we are referring to OCM component where basically it says where the artifact can be downloaded. With artifact, I mean a Docker image or a build Helm chart or something.
And if
like
you
that.
have multiple packages, yeah, and you would like to bring them together, how do you configure that?
What do you mean with multiple packages?
Yeah, let's say we had some discussions, and there are applications who have, let's say, a lot of different sub-services, yeah, and we can package them together, but then need to reassemble via the deployment. And now imagine you have this bigger rollout where you said you have hundreds of microservices that somehow need to work together. Is this a straightforward process, or do you need also to bring some configuration with it? So how the microservices interact together, how they are, and so on. Yeah.
Yeah, basically that's the task of the global control plane, and this is not ready yet. We are implementing it at the moment, but we wanted to make it as convenient as possible to create what we call a vector. This is, I guess, what you mean with packages, that you can do this as convenient as possible. So that assembling a vector with different sets of your microservices is possible. And then, I mean, creating the vector is just the beginning. That's where the promotion flow starts. And then we offer tooling for qualifications so that you can be sure that the things inside your vector, the services inside your vector are working together, properly working together. And yeah, basically that's the task of the global control plane. I'm not sure if it fully fits what you mean, but maybe
I don't know your naming conventions by now, because you introduced vector, but I understood the vector is nothing else as a description of multiple components.
Yeah.
Okay.
So it's basically an OCM component which references other OCM components.
Okay. And the reassembling, so in this OCM component where you then have the reference to others, you also then add the configuration for the ones that you are referencing.
So when we talk about configuration, we have to make sure that we do not mix things up, because we do add product configuration to the vector. That's true. So feature toggles, translation files, and I mentioned that at the beginning. But what we do not add to the vector is environment-specific configuration, because if we would do that, then we would automatically assign a vector to a certain landscape, or we would predefine where a vector can be deployed and where it cannot be deployed. That's why we enrich the vector then with environment-specific configuration in the local control plane.
Okay, I will think about it. Thanks.
Yeah, I mean, what I also think is really nice that it's also building on established functionality like OCM, and that you can use it. Do you need to use it in general, or?
Yeah, you need to use it if you want to use Konfidence, but it's not necessary that you have a touch point with it if you let Konfidence do all the vector assembling, OCM packaging, and so on. But we benefit from the features which we get from OCM, like signatures and yeah.